Now we move on to the first topic. The first topic is to find critical points of a given function. Now this is the function. To find critical points, there's a method. The first step is to derive this function, and next step is to equate whatever you derive to 0. Now over here, derivation of this function would be f dash of x, that is derivation rule. 2x to the power 2 will become 2x to the power 1. The rule states this: whatever the power is there comes down, and you need to reduce the power by 1. 2x, that's it. Power 1 will be x itself, plus 5. If it's only x to the power 1 or x, that will just become 1. And over here there is nothing, that means it's x to the power 0. When 0 comes down, this term goes. So whenever there is no x term, it's basically 0. So this is the derivative. Now what you need to do is equate this f dash of x equal to 0. That means 2x plus 5 equals 0, and the answer would be 2x equals minus 5, x equals negative 5 by 2, or negative 2.5. So this is the answer over here. So that is the critical number, but they have also asked few other things over here. Use the knowledge of the type of graph, parabol or cubic, and determine whether the critical number represents local maximum or minimum. See, now over here, looking at the function, this is a parabola and it's plus over here, so it's opening upwards. So whatever the critical number is there, it will be the minimum point. So this will be having the minimum at x equals whatever we found out, that is minus 5 by 2. And the parabola open upwards. Whereas over here in the second problem, you can see it will open downwards and it will have a maximum point. Whatever you solve will be maximum. So same method what we did, it will be opening downwards because there's minus sign over here before x squared, and that is the answer. Same way you can try solving others. Now over here it's cubic. So cubic is little hard because if it is positive over here, it will go like this. Okay, so now you will have two critical numbers over here. See, same method, you can solve this directly. Looking over here, derive it 3x squared minus 3, and then equate it to 0. Directly you can equate it to 0. It'll be 3x squared equals 3x squared equals 1. X is equal to plus or minus 1 because you have to take square root on both the sides. Now over here you will have 2. See, if you go and graph a x cube function, you will come to know it's like this. They have told you having the knowledge of the graph, parabola and cubic. Now over here there are two points, critical points, that will be over here and over here. So the left side one will be maximum. So whatever you get the left side, that will be lesser value. So in that plus 1 and minus 1, minus 1 is lesser. So that is first over here. That will be maximum. And this over here will be minimum. X1 is local minimum. X is over here local maximum. Similarly, you can solve the others. Over here, there is just over here in the solutions from the which I had initially posted, there was an error of minus. Over here it was taken as minus somewhere. Okay, over here it was taken as x of minus 4. That is wrong. When you solve it, you will get two answers, x is 0 and plus 4. And then, as I told you just now, you can solve it. You can have the knowledge of the graph. Now over here it's minus, so what happens is the upside is the left side. The cubic graph will be something like this. So the first value, the lower value, which is the lower value? 0 will be a minimum and 4 will be a maximum. So this is how we can solve having the knowledge of the graph. But now, say some cases over here, if we solve over here, you won't have a real solution. See, because when you solve this, the roots are imaginary. See, because you're getting imagined roots, there is no critical points if they are imaginary, if you cannot solve. So sometimes what happens is, if you have something like this, minus 1, you have to take square root on both the sides and you realize it is imaginary roots and there is no critical points. And also you must know one more thing. whenever you have just one point, say for example, over here you solved all this, and how many critical numbers are there? There is only one critical number. Whenever there is only one critical number, you will never have a maximum or minimum. These are few things, because if you do in detailed graphing, that is finding the f dash of x, taking the critical number and testing the values for positive and negative, you will realize there won't be a critical maximum or minimum point. So what to remember over here? Whenever you have x to the power 3, you derive it, it'll be x to the power 2, and you must have two critical numbers. But in certain cases, you will have only one critical number. So now, which is this function? A cubic function. Cubic function with only one critical number is neither local nor maximum. So this is very important to remember. This will be neither local nor it will not be a local maximum or minimum. So this is neither, that is the solution. There is one critical number, that is neither. And now if it is x to the power 4, see, this is hard to remember. This will be similar to a parabola. It will be something like this. Okay, but it's still hard to remember. Now, honestly speaking, you may not be exactly 100% right on which is the top point and the bottom point. So in such cases, when you have x to the power 4, it will look like a parabola, like this shape. You can try it in the graphing calculators. Now, what you can do is, I will do a method over here. So first, you need to derive this. That will be x to the power 4x to the power 3 minus 4x. Okay, and then now you need to solve this. You can solve it in various methods. Now, one of the method would be by calculator, that is mod phi and then option number 4. And what do you get over here? You'll get 4. Sorry, you need to substitute the values first. 4, x squared is not there, so it's 0. And lastly, minus 4, and there is no number, so it's again 0. So the critical number x1 is 1, minus 1, and 0. We got three critical numbers. You can see over here the critical numbers are x minus 1, plus 1, and 0. Now, how do we know which is local maximum and minimum? If you have the knowledge of the graph, yes, it's possible, but still there is one more method. This is a standard method. You should know this because you need this knowledge in the coming problems. All you need to do is say the critical numbers are found out by the derivative, isn't it? Plot them. How do you plot them? Say now 0 is somewhere over here in the ascending order, minus 1 over here, and 1. So this equation, the derived equation, is important. Now you need to test some values. Okay, test some values. So let us take a value less than 0 but greater than minus 1. So it will be minus 0.5. Over here you need to take one more value. You can try with others. You can take 0.25. You'll get the same positive or negative value. That's it, what we want. Then over here it's 1.5 minus 1.5. So what you need to do is, these are the test values. You need to put these values in this derived equation, not in the initial equation, the derived equation, and then check the value is greater than 0 or less than 0. We don't care about the value, we just care about it's positive or negative. So what we do is over here, now put over here 4. So mod 1, 4 bracket, because it's minus over here, minus 1.5 the whole cube, minus 4 into 1.5. Sorry, minus 1.5. That's it. The answer we got is negative. We don't mind whether it's 17.5 or anything. We just want minus or plus. So what I'll do is write over here minus signs. 1 is enough just for understanding. It's negative over here. Then I need to change to what? 0.5. Let me change the x values to 0.5. Okay, now I'm getting a positive value over here. Now again change it to positive 0.5. I'll change the negative sign. I'll remove the negative sign. And now again I got a negative sign. And then I will have to change to 1.5. So it's again a positive value. So what I am getting is positive when I put a test value less than -1, and over here also, sorry, negative over here, positive, negative, positive. What this says is the way the function is increasing and decreasing. So before the domain of x minus 1, the values are decreasing, so the graph will be going downwards. Then over here it's increasing, it will go upwards, then again down, and lastly again up. So now you can easily understand which is the local minimum and maximum. See, the graph is something like this, going up, going down, and then you know it is a parabola, so it will go up, and over here also it will go up. This is the shape of the graph. Now, which is the minimum point? It is -1. So you can see that not only -1, even +1. X of plus and -1 are local minimum, whereas this over here at 0 is maximum. That is how we find it out. And the last problem can be done same way, but over here when you do the same method, see, I will just show it over here. The critical points are 0 and 9.4. So 9 by 4 is about 2.25, and this is 0. So what happens is over here, you will have minus, I'm not sure, but you need to try this trial. Let's take, for example, minus 0.5, and we will just do this quickly. And over here, I'll take 1, and over here, I'll take 3. Okay. Now, let us try these values. We have to put in the derived equation, that is 4 multiplied by x, that is minus 0.5, the whole cube, minus 9 into minus 0.5 squared. Okay, this is done. Now over here there is a important thing. Press equal to, over here it's minus, so now it's fine. Now the important thing is doing the same thing in the derived equation, because I still remember some of my students try to put it in f of x and they got the wrong answer. Don't put it over here, do it in the derived equation, because this is the critical numbers are from the derived f dash equation. Okay, now try the next one. So the next one is 1, so I will just change it over here to 1 instead of x, 1 over here and 1 over here. So what is the answer I'm getting? It's minus. So again, I'm getting a minus. And last one, let's try 3. Now let's put 3 over here and 3 over here. And I'm getting a plus. So over here, it's plus. So what do you understand over here? This part, it's decreasing. Again, it's decreasing. Only over here, it's increasing. So the graph is something like this. Only at 9 by 4 it's increasing, so the critical value is only over here. See, this is a minimum. 9 by 4 is a local minimum. Why? Because it's decreasing. Whereas 0, no, it is neither maximum or minimum. Why? Because it does not change. Only if this changes, the sign changes, then you will have maximum, minimum. So if you have the knowledge of the graph, as we did for the first few problems, it's easy. But if you do not, it's very hard to understand this exactly. So it's better to do the method I just did, and then you can check the answers. Over here, detailed methods are there. You can see over here, it's directly from the knowledge of graph. But in the coming problems, coming topics, we will see the method again and again. So please make sure you understand the writing the critical numbers and testing the values.